It's the 17th of January, 2015, and this is episode 179. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future. Today on Let's Talk Bitcoin, I'm here with Andreas Antonopoulos.
Hey, everyone.
And today joining us for a conversation about the future of decentralized organizations, two of the men behind Eris Industries, Casey Kuhlman.
Hello.
And Preston Byrne.
Hey, how you doing, Adam?
Pretty good, Preston. Good to see you again.
Likewise.
So let's start from a high level. What is Eris Industries doing? You guys haven't been around that long, but you've got some pretty exciting stuff.
So what Eris Industries is doing is we're trying to provide developer tools that can help developers build things on distributed systems and with smart contracts. So that is the brief overview of what we have going on. We really consider ourselves a dev tool shop, and we think that a lot of what has happened at the platform level. I think we could look at the problem set a little bit differently if we look at the distributed systems from an end user application developer perspective. So that's what we're trying to do.
In sort of more layman's terms, what we're attempting to do is we're attempting to take blockchain databases and we're attempting to make them useful in the hands of individual developers for very specific applications. So rather than looking at the blockchain as an entirely open platform, which needs to be used by everybody for every single application, this is something where a developer can parameterize who they want to use it and for what purpose they wish to use it and what function it's going to carry out. As a result of that, we have a lot of freedom in how we designed Thelonious design, which is a derivative of the Ethereum blockchain design. What we've done is we've created a blockchain design which can be controlled, it can be secured without mining, it can amend itself over time without necessarily needing a hard fork, simply on command to a smart contract kernel which is put in the Genesis block. When you add all that together, you have a blockchain design which is really very flexible and very controllable, in that if you can write a script which describes how that blockchain is meant to function, the blockchain will then function in that way. As Casey said, it's a developer tool. Rather than looking at blockchains as something where you have a general platform like Bitcoin or Ethereum, which is meant to have things tacked onto it, this basically puts the power and responsibility on developers to parameterize a blockchain which performs a particular function in a particular way.
When you say parameterize, you mean to specialize a blockchain and to almost kind of, like if Bitcoin is a general purpose kind of neutral platform, then the things you're talking about aren't necessarily that. They're kind of just whatever they need to be, right?
Exactly. I mean, one of the first examples we came up with was version control. We're working on a prototype for that now. But we're a startup. We have 5 guys, and we pay GitHub to be exposed to the risk of their servers going down and problems with their SSL certificate. So from our perspective, we said, okay, well, here's an idea. What if we could just script in something which displayed in an ordinary web browser, and that's what a Thelonious app does. It shows in an ordinary run-of-the-mill web browser. And what if we could have something which displayed in a web browser, looked like GitHub, felt like GitHub, acted like GitHub, but only had 5 nodes on the network, and then the CEO, Casey, held the keys. And then what if you extend that analogy to other things? We're leveraging the blockchain and the distributed internet to provide a secure and uniform logic to the interactions that we want to have with each other. To sort of show you where we're going with that, we've currently finished the back end to a distributed YouTube, which may not make a lot of sense to people saying, well, why don't you just use Google? It's free. How is this more efficient? But we would say something like, well, if you can do a distributed YouTube, that proves the concept that you can move all kinds of data around and govern access to all kinds of data with a blockchain database acting as your application logic. And then you have all kinds of other applications, DRM. Musicians could allow people to download their files directly from them, letting a blockchain do all the heavy lifting instead of doing it on unfair terms with Spotify, for example.
Looking at the development of the Eris Industries platform from a developer perspective, it's very familiar to me. It's an MVC model. It looks a bit like Ruby with some elements of Node.js. And it seems, at least from an outside perspective, that you treat the blockchain the way an application development tool would treat a database. So you can essentially emerge with a schema and modify it and version it and evolve it over time. A model which will be extremely familiar to developers using Ruby or other platforms like that.
That's exactly the idea.
And the way that you can control schemas is quite interesting when using an Ethereum derivative blockchain, because what you can do is basically establish what we call smart contract factories. And those act as the schema to establish some sort of framework for how a particular piece of data might be treated. So in other words, a factory can spawn a new contract, and you know that the contract that has been spawned will have a data schema similar to like a row in an SQL database table. It won't work exactly like that, but it'll be roughly in that area. But when we did our first proof of concept last summer, we really looked at this and it seemed to make sense. You can build applications in a way that people know how to build, not in a way that requires you to dig into a Qt format and worry about building desktop applications. You must deal with all kinds of edge cases in different desktop environments. We said, forget that. Let's just build in a way that we all know how to build. Well, not all, but a lot of people know how to build in the web browser, and structure an application in a way that is familiar and approachable to a wider range of people. And that's exactly what we're trying to go for.
Now, within each of these distributed or decentralized applications, you have a purpose-built and evolving blockchain acting as the data store, much in the same way that in a Ruby application, you'd have perhaps a NoSQL database or even a structured database, relational database acting as the data store. These are standalone blockchains implemented using Thelonious, the Ethereum derivative. How do you secure a blockchain that has only a limited number of users? Help me understand that.
I mean, generally, the process is called committing. So we don't actually use mining, although our default is SHA-3 proof of work. What you do is when you set the control parameters in the Genesis block, you can specify which nodes are allowed to add blocks to the end of the chain. So let's say you're a bank or some other kind of financial institution and you're running some kind of ledger. For an application like that, you're not going to want the general public adding blocks to the end of the chain. So you simply say in the Genesis block, it's important to note that when you're dealing with an application, the logic of the entire application relates back to a kernel, which holds the vast majority of both the chain's logic and the application's logic in the Genesis block. So instead of having your blockchain having all of its consensus and security parameters hard-coded into it, it's something which you drop into the Genesis block into a smart contract, which then you can amend by broadcasting a transaction which relates back to that original contract and adding it to the end of the chain. So with this, you can specify which nodes are able to add blocks to the end of the chain. And if a block is added to the end of the chain if a node or some other actor attempts to add a block to the end of the chain and they haven't got the relevant private key, that block isn't added. It's rejected by the processing nodes as invalid.
Let's relate this back to the technology our audience already understands. So, for example, today on the Bitcoin blockchain, there's quite a debate going on over whether the block size should be increased or not. And that decision involves a hard fork. If there is to be an amendment to the block size, as happened in April of 2013, that would involve a hard fork. Older versions of the code would no longer support blocks mined at a larger size, and this would force miners to make a decision in order to participate in consensus. Essentially, the consensus mechanism is hard-coded in the software and increasingly being moved into its own library called libconsensus. Now, that model is very different from an agile MVC development model where the parameters of the application are encoded in a data schema or model that can be evolved. And what you're saying is you've taken that and put it into a smart contract that sits on the Genesis block. So that, for example, if you wanted to add a new transaction type or some other change that is not backwards compatible, you would evolve the smart contract in the Genesis block and the blockchain would start behaving differently. Is that a correct analysis?
That's exactly correct. So to extend a little bit what you're talking about, there's a variable that sits within the Genesis DUG contract that sets what the block time is supposed to be. So if for some reason a developer has set that, let's say, really fast because they're testing out their application and getting used to what it can do, and at that point in time, what they really want the chain to do is to just be super fast, so it can mine really fast. And let's say this chain is meant to be just an open chain. so that anyone can mine on it. And it doesn't have restricted committing, or what we call committing, what other chain designs call mining. So over time, then what can happen is the person that has, or the nodes that have permission to change the DUG contract, they can change the variables within that DUG contract to, for example, make that block time be a little bit longer or a little bit shorter. And those are things that are really like an administrative level decision that probably should be made by somebody that understands chain design, that understands the trade-offs between the different consensus parameters that come into play. And there's really sort of three problem sets that we're trying to get at with Thelonious. So we're not trying to do everything, but we have identified sort of three primary use cases that we want to go for. One of which is someone is an institution that is concerned about regulatory risk and has to have some control over what that data set is doing for whatever reason. Because of that, we have an ability to restrict the number of nodes that can commit to a particular blockchain. We also want to be a really flexible but lightweight small chain for applications. And in that scenario, typically, they would probably be committed in the same way that Ethereum works. And yes, they would be less secure, but you would probably use them for things that weren't monetary, and you probably didn't need a lot of security on that chain. Preston likes to say, what does it really matter if you double spend a cat picture if all you're really tracking on this particular blockchain is pointers to hashes of cat pictures? Then it probably doesn't matter. And if there's no real value in attacking the chain, then maybe you don't really care if you have a low hashing power on that chain. Then the third problem set that we really want to go for is we want to, as you were saying about move lib consensus into its own library, we want to take that library and actually move that into the distributed virtual machine itself, and move the entire consensus parameters out of the blockchain client and into the virtual machine. So as Bitcoin has a small virtual machine that its clients use, Ethereum has an expansive virtual machine that it uses, and we build upon that by adding different opcodes in that allow us to start building consensus models within the VM. So at this point, then the chain becomes self-defining. We're not fully there yet. We have some more work to do to move consensus into the VM itself. But at this point, Thelonious, you can define a lot of the parameters. It's not as flexible as we would like it to be. But once we finish up moving the consensus mechanism into the VM, then we'll really have an ability to really explore different consensus parameters, allow people to have basically packages that they can publish either on GitHub or wherever, decentralized GitHub, which have different consensus parameters in there. And hopefully developers will be able to just pull those off the shelf, just as they might do with a set of model files or something like that in a typical web application. Pull those down, add them to the chain, deploy the chain, and then start working on making the application and really start to ease the way in to getting real utility out of this stack. We haven't really talked about it too much yet. Hopefully we'll get to it, but we're just talking about Thelonious now, and that's one idea on the blockchain side, but we have a whole distributed application server that will talk to a whole range of blockchains as well.
In your vision of having the consensus mechanism be a part of the application's parameters that can be evolved as part of the application, essentially moving them from a control structure to a data structure within the application, do you see a model of consensus that is kind of the hard consensus of Bitcoin, massively decentralized, hard consensus designed to bootstrap a global currency with long-term value? Do you see that as an edge case of what you're doing, where you could just tweak the parameters and essentially emerge a hard consensus chain? Or is that really outside of your scope? You're not interested in that kind of massively distributed, trustless world currency level of hard consensus?
I think that's one end of the spectrum. Our idea is that by moving consensus into the VM, we can provide a whole range from a completely Bitcoin derivative style consensus mechanism all the way down to a very locked down consensus mechanism where, as we were discussing before, 5 nodes on the network can create contracts, can commit blocks, and can transact. And only those 5 nodes can do that. I think we want to be able to do the whole spectrum with those 2 examples sort of bookending the spectrum.
One of the things to consider, Andreas, is that when you can script in your consensus parameters, you can do some pretty interesting things which are designed for global applications, but don't necessarily require your kind of global currency model in order to administer. So let's say you have something like Amnesty International or Greenpeace or some other large stakeholder organization where they need to have a governance mechanism which reflects the needs and beliefs and desires of the community that supports them. You could do something where you have a framework which is basically a consultative framework. And so in that kind of an instance, you might want the administration centralized, but you might also want the database itself to be distributed so that people can see how decisions are made, transparency as how those decisions are made, and how consultative mechanisms with those communities are carried out is promoted. Thereby, you also might want to change the way that those decisions are made. And you can set parameters to change that in code. So you could say something like, we have this one particular mechanism which allows us to consult with the various stakeholders who have registered with this chain. And if we want to change the way that that works, we can do it if 2/3 of the users who have been, active in the last 10,000 or 100,000 blocks approve the change, and then the code will automatically update itself. So what you have is a mechanism which can streamline communication among very large groups of people and automate that process very easily. And that's not necessarily something where you'd want a cryptocurrency. You could have a totally open model where anyone can register on the chain. You run the risk there of having something like a Sybil attack take place. But it's a way that you can open things up and automate the way that you communicate with people on a global level. And voting and governance is one such application. And you can talk to them very securely within the context of the relationships that you've defined.
Can you guys talk about the concept of a virtual machine in the context of how Bitcoin does it and how it's different? Because I think that a lot of people don't really understand when you're talking about decentralized systems, that's really what's happening, is that it's like a time synchronized step by step and then verified every step of the way to make sure that everybody who's up to date is actually up to date. But it's actually like a distributed computer that's actually working all the time. And you were talking about how the one that you've built in Eris or the one that's built into Ethereum is more featureful and more complex. What does the Bitcoin machine look like compared to the Eris machine?
If I'm honest, I don't know that virtual machine very well. Here's what I do know about the Bitcoin virtual machine. It is there. It was purposefully crippled by Satoshi. As Charles Hoskinson said when he was introducing Ethereum way back in the day, the idea that Satoshi had when he was first building Bitcoin was to put a virtual machine there, but to purposefully cripple what it can do. And this is why, as far as I understand how the way that Counterparty and Mastercoin and other meta coins that work on the Bitcoin blockchain, as far as I understand the way that they work, they just deal with information that's sunk into the blockchain in a different way. And my understanding is that they have a different virtual machine that reads information and then saves information back into the blockchain. As far as I understand, the main things that the Bitcoin virtual machine can do is to verify the signatures of the transaction. There are a few other opcodes that the Bitcoin virtual machine has, but the virtual machine has very few opcodes, and it was never meant to be a Turing complete or what a fully scriptable virtual machine. It was always meant to be a very, very simple virtual machine that would do things like verify blocks, verify transactions, and stuff of that nature.
Basically, Eris is the opposite of that. Eris is you can do, just about anything. I guess it's not as packaged. Those the specific things that you can do in Bitcoin are very well defined. It's very clear what you can and can't do. Whereas with Eris, because you have so much more capability, it's a little bit more obscure. You can do more things, but you have to figure them out.
Exactly. So it's sort of the difference between filling in a web form and sitting down at a text editor or a blank sheet of paper. So that's kind of the differences in how the virtual machines work. If you're filling out a web form, you're highly constrained as to what information you can put into that. And that's very efficient because of, on the back end, how that data ends up being processed. You want phone numbers to have a certain number of digits, and you don't want them to have letters. You just want them to have digits. And that's how you know that you have a good phone number and things like that. In a web form, it's highly constrained. But if you sit down at a text editor or a Word or anything, you're not constrained. You can write 1, 2, 3, 4, A, B, C, D, E, F if you want to. And the computer's not going to tell you, no, you can't do this. It would probably be nonsensical. But you would have to figure out how you were trying to craft that communication or whatever you were trying to do. Whereas on a web form, you'll have the computers help you along the way, but you don't have as much freedom. I think that might be a fairly accurate description of the trade-offs between the two styles of virtual machines. And to be fair, the Eris virtual machine is a superset of the Ethereum virtual machine. So Ethereum has built most of this virtual machine capacity. We've extended it and added a few other niceties to it, but they did the heavy lifting by far.
So far, we've talked primarily about the parameterized and dynamic model of consensus in the blockchain component Thelonious. But as Casey said, that's only one component of what you've built there at Eris Industries. The other two components of great interest to me, at least, were the distributed application server, DServer, as well as your legal markup language. Can you tell us a bit about those?
Sure. I'll start with Legal Markdown because that has been my baby for a couple of years now. So Legal Markdown is a way to simplify contracting for real-world contracting. And I'm not talking about smart contracts. I used to be a lawyer. I guess I'm still technically a lawyer, although I do software now pretty exclusively. But there's a way that programmers approach how they do their work that I think that a lot of lawyers could really benefit from. And one of the ways that programmers deal with their work is they have classes. For example, in most languages, you'll have a class or something like a class. And what that does is it creates a default, basically, object or thing. And then you can, what programmers call, instantiate that object. Or in other words, you can create an instance of that object by passing a set of parameters to it. Now, what Legal Markdown does is it allows you to take a template file of a particular contract, and you can pass a set of parameters into that template to get an actual contract that is for this particular deal. So I would go into meetings with clients, and I would be able to sit down with them to understand what they were trying to accomplish. And soon after that, rather than having to go back in and start writing a contract from scratch, which very few lawyers would actually do, or actually building it from a template, all I would have to do after that is fill in a few blanks. I would push a couple of buttons in my text editor, and I would have a full PDF of the contract ready for those people. Now, there are templating languages that work with Word that do roughly analogous things. But the advantage of Legal Markdown is because we're using plain text document, is that you can script that whole thing a whole lot easier. So we have this idea that smart contracts, sure, they can exist outside the law as a lot of people may like them or want them to exist, but they could also operate just fine within the law. And so we have this idea that we call dual integration, where you would make a real world contract and you would save the PDF of that. You would get the hash. Basically, this is what proof of existence is doing. Then you would take that hash and you would put it into a smart contract. And before you made the PDF of the contract, you would log what the contract address was of the particular smart contract. So what you have at that point, you have a smart contract that refers to a particular hash of a PDF file that exists somewhere on Earth. And you have that PDF file having the contract address and hopefully the chain ID, because in Thelonious we use this concept of chain IDs, with particularity you could say that this smart contract and this real world contract are interrelated to each other. At that point, you have the backstop of being able to take a contract to court if you need it, but you also have the efficiency of being able to have the smart contracts manage the data of that interaction. And that's what we think is really powerful with Legal Markdown.
I think an important point to follow up in more general terms in the decentralized space has been ignored, is that if you want to have an enforceable contract in the legal sense, you have to have the possibility of enforcement. So one thing that we've seen with a lot of frequency in the smart contract space, and you know, what is a smart contract? It's just a self-executing actor on a database. You see people saying, well, smart contracts are going to allow people to do all kinds of financial transactions without the financial system. And I'm not necessarily certain that that's true. A, because they're very, very simple, whereas financial transactions are very, very complex in the sense that a smart contract is a couple of lines of code dealing with data, with the underlying subject matter being a token, which is meant to represent an asset. But, you know, a representation of an asset taking the form of a token does not necessarily encompass the full complexity of that asset as represented by a set of enforceable legal documents. And also in the sense that if you have something which is just a pure set of payment mechanics, that full complexity, which I've just referred to, isn't necessarily incorporated by reference. And in most financial transactions, you need it to be. So what this would allow is setting up, you know, you need the legal nexus. And in order to have a legal nexus, you need a third party of some description somewhere in that transaction. That you can have a legal nexus without a third party, but it almost doesn't make logical sense. because if you're going to enforce something, you need to have the ability to step in, and that's someone else who's doing it for you. So whether it be an Oracle or something like a professional trustee or a custodian or a court, they're going to need to understand when smart contracts are managing financial assets, what the specific prosaic legal terms of that particular transaction are. And so what this allows you to do is take a set of payment mechanics, which will, you know, let's say you're negotiating a structured note of some kind, and you're the lawyers, and you're negotiating the deal. When that deal is done, because you have legal markdown, you're going to be able to just push a button, and then the counterparties, you know, all of the bank's systems will all be able to agree that this is how the payment flows are going to work, just because you've structured it into the legal document from day one. But it doesn't necessarily mean that you want to have the placement of every single comma in the document. You know, there's the old joke, if you put a comma in the wrong place, you change the meaning of something. And you know, that's all lawyers do. But the fact is, that's actually what happens. A word in the wrong place, a comma in the wrong place, changing, you know, one word to another, which is similar but only ever so slightly different. That's stuff that we used to do all the time to try to improve our client's position vis-a-vis their counterparts. And so you don't want to necessarily script all that because, you know, when the deals take 6 months to a year to negotiate, trying to then script all that into code is going to just add labor rather than reduce it. So in the sense, you're getting the efficiency of the legal system simply by incorporating it by reference. And Nick Szabo said this. He said, we can get digital institutions up and running much more quickly if we leverage the complexity of the common law system, which is an iterative process. It's a discursive algorithm in a sense. It has learned from its mistakes and come up with a very comprehensive body of rules. And we said there's no sense trying to throw the baby out with the bathwater with decentralization if we can benefit from and leverage those rules while still using the technology to make these transactions cheaper and more efficient.
This gets back a little bit to the security model. I think in a lot of distributed protocols, we end up spending 95% of our time getting that last 5% of either verifiability or trustlessness, depending on what your perspective is on the situation. And our idea is that the law that currently exists could actually do that 5% quite well. And a lot of people have said, well, why would a corporation use a blockchain to us? And we've said, well, that's up to that corporation. And whether you want to trust them or not, you already probably are trusting them, or your peers are trusting them, whoever their customers are. If they're a big corporation, they probably have a lot of customers, and they probably have a lot of people trusting them. And the idea that if they're going to roll back a chain maliciously is problematic for people, well, they can have an ability, because that particular blockchain has the legal nexus to that particular corporation, then you can have all kinds of real world legal consequences for taking that action, which you wouldn't necessarily have if you had a platform that was without an identified operator.
Right. And it still has all of the audit and transparency capabilities of a traditional blockchain. This is a topic I find quite fascinating. A lot of the blockchain 2.0 technologies we see are attempting to create this fictional world where DAOs and these things can exist outside of the law. I think Pamela Morgan put it best when she said, you can book the Airbnb room on the blockchain with a multi-sig escrow, but you'll still need the legal structure when one of your guests end up floating face down in the pool in the morning. Because there are always externalities. How do you encode that liability in a smart contract, right?
You can't. I mean, these are very subjective and qualitative considerations that you can try to put into code. But as the facts move on the ground underneath you, your code isn't going to be able to keep up with it.
It's also extremely inefficient.
Exactly.
One of the things that could be used to explain this very easily to programmers, in legal contracts, a single word can act as a macro that does a hash include of 10,000 pages of established precedent and definition, right? So, the word person, the word consideration, words like that in legal terms are magic words. They're macros. And what they do is they allow you to, by reference, include hundreds of years of established precedent and legal definition that allows you to have complete disambiguation of terms. One word worth 10,000 pages. That's a really powerful tool if you know how to use it. That's why lawyers get paid a lot of money to use those powerful tools. I really like how you've built this legal markdown platform. In fact, I think as a programmer, I look at that, it reminds me of Jinja templates in Python Flask or Haml or Herb or Sass or any of those kind of web templating languages. And it's something that I could quite honestly use as part of the Eris system today just to do my own contract.
And that's what we were really hoping to go for.
Yeah, we'd be down with that.
This episode of Let's Talk Bitcoin is brought to you by CryptoKit.com, the easiest, fastest way to send Bitcoins right from your browser. That's KryptoKit.com if you'd like to learn more. Today's magic word is Eris. That's E-R-I-S. Eris. You've got until the 20th of January to visit letstalkbitcoin.com at the Let's Talk Bitcoin iPhone app and enter it for your share of the listener rewards. Tokens by themselves are useful in that they're secure, but whatever value they have beyond that trait common to all cryptocurrency must be given to it by the systems that accept it. LTBcoin was launched because we wanted to start giving back a token to those who are powering the network. We could do that with just the token alone. Creating redemption services that can take advantage of these new, cheap, and really secure but not inherently valuable tokens took a bit longer, but our work is starting to yield results with Tokenly. I'm very pleased to announce the launch of the multi-token LTB network sponsor tool. If you have Bitcoin, LTBcoin, Sponsor, Our Console, LTB Display, or a growing variety of other tokens, you can think about this tool as a redemption engine. Shows, writers, editors, and personalities can accept audience donations and give back rewards. Those rewards can really be any number of things, and at launch we've got Stephanie Murphy offering various types of voice work, podcast sponsorships available on John Barrett's Bitcoins and Gravy, John Light's decentralization-focused P2PConnects.us show, and of course the Let's Talk Bitcoin show. This is the exclusive way to secure one of the few display advertisement spaces on the front page of Let's Talk Bitcoin. Rob from the Bitcoin Game is offering 10 packs of cast metal Bitcoin keychains, and this is also becoming the exclusive method for booking my consulting time now in both hour and half-hour increments. You visit letstalkbitcoin.com, click the sponsor option in the top menu, and read the rules for using the service. Spoiler alert, you're making a non-refundable donation whenever you send us cryptocurrency. Please comprehensively read the rules. They're not long and are designed to be understood. Once you've agreed to the rules, you'll be shown the sponsor form. Here you can select the type of sponsorship you want, and the show, blog, or individual who you want to support, and the type of reward package you're interested in. This isn't so different from your average web form until this point, but at the end of the form, you're prompted to pick the type of token you want to pay in. Which tokens are accepted are set by the person or group who will be receiving the donation. And while all items must have a price in LTB coin, they can also have prices in Bitcoin, Swarm, NicePlum, Tatiana coin, or any other token the project wishes to accept. These prices can be fixed or they can float based on market value. It's all up to the person doing the listing. Once you've selected your desired sponsorship and the token you want to pay in, click Submit and you'll be prompted to pay the specified amount of your desired token. As soon as you've done that, the system detects the transaction and sends all your information plus a payment confirmation to the contact person for the sponsorship package that you're interested in. That contact person then contacts you to work out whatever the specific details are. In addition to the sponsorship tool, we're now conducting public testing of our first multi-token vending machines. If you want to buy a sponsor token, which can be redeemed for a 45-second on Let's Talk Bitcoin, you can send the appropriate amount of Bitcoin, LTB coin, or any other type of token accepted to the vending machine's address, and it'll send you back a corresponding amount of sponsor. This can be done with any token, and you'll be able to use an interface to create your own vending machine soon. I'm going to wrap this up, but there's one more thing. I mentioned all items have LTB coin prices, and that's true. What I didn't mention was in most, if not all cases, and the more official LTB network you get, kind of the bigger the discount is, the LTB coin price is substantially lower in terms of actual value you need to spend to acquire these things, instead of using Bitcoin or another token. To this point, LTB coin has been a token whose purpose was to be given away for a time in the future when it had value. Today is a milestone, and the next part of our journey seeking value begins now. You can find the sponsorship section at letstalkbitcoin.com at the top of the page where it says sponsor. Thanks to everyone for their support to this point, and even more for the support yet to come. This seems like a really, really broad tool in terms of the things that it can do, much actually broader than something like Bitcoin, which, for better or worse, is kind of enforced as neutral. And that's sort of just the way it is. It's sort of difficult to change. It is changing over time, but not so much as something like this would. You've mapped out scenarios where you have, like 5 stakeholders and, one of the people mining is on the CEO's phone, something like that. And then you've talked about others where like a percentage of the network, 2/3 of the users of the network have to make a decision in order to make that sort of change. So ability is to a certain degree responsibility. If you can do something, if you can censor something, then it's actually your responsibility to censor something if it goes against the current legal environment that you exist in. What do you think about the idea that as these blockchains get more specialized, it almost seems like there's a centralization of purpose? The structure remains decentralized in that you can take this and you can create whatever it is that you want with it without asking for permission. But each individual blockchain and project sort of becomes its own little kingdom that has vulnerabilities unto itself. There's not really much of a question there. I'm just kind of trying to work this out in my head. Are you concerned about liability for your end users? Are you concerned about censorship resulting from the ability to simply do these things where before you can't?
And there's a trade-off. If you're dealing with a fully open public blockchain where no one can exercise control and no one can be blamed, that's one thing. But you're not there achieving the kinds of economies of scale that you can get if you have blockchains which are addressing very specific pain points. So to a certain extent, yes, there's administrative centralization involved if you're looking at something which is securing itself, because that's necessary in order for the application to be efficacious. On the other hand, we saw this as taking all of the things that we liked about Bitcoin from a security perspective, from a simplicity perspective. And we said, well, this is something which people should be able to use for any purpose they want. They need a general purpose database, which isn't necessarily tied to the cryptocurrency model in order to do it. There's always that trade-off. I think in terms of a liability and responsibility perspective, we're under no illusions that, like every other technology in the world, blockchain technology is going to be used for nefarious purposes going forward. We do have a personal problem with that, but we have to do what we're going to do, and that involves open sourcing our code so that it's secure. So you have to accept that with that degree of technological advancement, people are going to use it for just like the internet is used today. People are going to misuse it, but we think that the trade-off, which is that people will be able to benefit from it and get a higher degree of privacy and greater control over their data and more security over how they interact with one another, we think that it's probably it's almost certainly worth the trade-off in the sense that now what about the current model model where you've got 5 or 6 really big stacks. You've got Amazon and Google, being the 2 largest software stacks, which everybody uses on a day-to-day basis. The trade-off there is that when you use their stack, they read all of your information, they give it away to the government so their legal overheads stay low, and they sell it to advertisers who know everything about you. In order to get the utility of an interactive application and communicating freely with whom you want to communicate, any Google Hangout you do, right? Great, we get this free service, but we have to Google. And so from our perspective, the blockchain allows a pretty ready-made and easily reproducible way that you can set up a network, a peer network, which allows you to predictably know the parameters on which you're communicating with others and set those in advance. If someone decided they wanted to set up the Silk Road, would they or should they be held responsible? I think if you think that the laws should be consistently applied, then yes, that would be the case. But if someone were just setting up a communications network for their office or a social network, or really anything you can think of, should we deny that utility to those people who are using it for above board purposes in order to either reduce their costs, reduce their reliance on third-party service providers, or increase their personal privacy? Do we hold back technology, deny them that utility because someone's going to set up Silk Road 12.0? I think the answer is no. We don't hold it back. We see this stuff as being profoundly useful and potentially changing the entire structure of the internet.
Well, Preston, the way that you guys are setting this up, though, is built around specificity. And so one of the reasons why Bitcoin is a resilient network for building specific things on top of its general platform is that in order to attack any of those specific things, you actually have to attack the entirety of the network. So there's good sides and bad sides. Certainly there are benefits to the approach that you're taking, but are you at all concerned about individual chains coming under attack simply because but I guess mining really is just a number that we give to ourselves, right? It's a way to measure our own influence on the network relative to anybody else. So maybe it doesn't matter.
Exactly. It's hard for us to compare Thelonious to something like Bitcoin on a one-for-one basis. I think that for us, the key here is to get more people in the mindset of having distributed systems. And we think that Thelonious is concerned about having individual chains be DDoSed or attacked. That is a concern. But that's a concern across the board in interactive applications. That is not a blockchain concern. That is not a web app concern. It's just any networked application is going to have that as a challenge that they're going to have to overcome. Really what we want to do is to make it easy for more developers when they have a new idea to say, wait, actually, maybe I could think about doing this in a distributed way rather than doing it in a traditional, I'm going to pull Rails or Django off the shelf and I'm going to roll a MongoDB database or a MySQL or a PostgreSQL database and I'm going to put that on the back end. Well, actually, maybe we could try thinking about it in a more distributed way so that our users may be able to participate in having the security of this network, or maybe they won't, depending on what trade-offs we decide. I think from Eris Industries' perspective, our role in this is to be very educational about what the trade-offs of different consensus mechanisms are. Then really leave it up to developers to make the decision based on their application as to what they think is most beneficial for them.
Preston, I read an article that Dan Larimer wrote on the BitShares blog a couple of weeks ago. I saw that you had a response to it, and I got, I think, largely the same sort of heebie-jeebies from it that it seemed like you had, and I kind of wanted to talk about it here a little bit. The gist of the article was basically that BitShares is rolling out something quite similar to this in that you can start your own token. This is designed for the idea that people who accept dollars and give people back dollar tokens can create their own dollar token and then administer that. And in the administration of it, they have the ability to freeze trading of their asset. They have the ability to change and reassign balances of any user who has their asset and a couple other things too. That's really kind of the core of where my concern is that I see that once all of these structures exist and the ability for this stuff, essentially proactive censorship to happen within these projects simply because the responsibility is there. Whereas again, with something like Bitcoin, there's not really anybody who you can throw in jail or blame for it.
Is the question, once you have a private chain architecture, that chain architecture can be censored by virtue of a government agency serving a warrant on someone and saying, right, this chain has the...
Well, or anybody. I mean, we've seen recent terror attacks around the world for a variety of reasons and a variety of contexts. Again, if the ability exists in order to censor, or isn't the responsibility to censor on the person who has that power?
Yes, but We aren't proposing here something which is designed to replace Bitcoin or something which is designed to replace any of the existing fully decentralized architecture. It's really meant to complement it and fill in the gaps where you don't necessarily want a Bitcoin involved in mediating these transactions because, for example, it might bloat the chain to a prohibitively large size. So, for example, Gavin Andresen, his recent proposal to increase the block size to 20 gigs has been met with derision from from quite a large segment of the Bitcoin community, such that I saw it referred to as the hard fork missile crisis, the blockchain civil war. I think he does have a point, which is that if you're attempting, probably that revision is meant to accommodate additional functionality, things like side chains, where you're going to have a lot more data moving into and out of the Bitcoin blockchain. But then you ask yourself, what is the aggregate consequence of that going to be? And that's going to be that ordinary people are really not going to have the ability to run a full node anymore. And it's going to be down to server farms, and there's going to be an increased degree of centralization. So what's the alternative to that? Well, you can either continue to build meta protocols on top of Bitcoin, or you can build side chains that talk to Bitcoin and various other things. And you can rely on Bitcoin for every piece of distributed information you need. Or alternatively, you use Bitcoin only really for the stuff which needs and warrants the fully decentralized network. And then for other sorts of private information or other types of distributed interactions, people will be operating on distributed platforms.
I think a critical component of this idea is that Bitcoin separated the tool itself from those using the tool. And that actually provides a significant shield against liability. With the evolution of these more abstract forms of development tools like Eris or Ethereum or other kind of blockchain customization tools, you add yet another layer of separation between those who build a tool, those who use the tool to build an application, and those who are actually responsible for running the application, which diffuses the liability even further. So if anything, I think this provides additional levels of shielding between those who control the network, who may be many, and any kind of liability that may befall them.
Liability is a tricky one because it's fact dependent. So let's say you've got your Silk Road type marketplace. Liability there is everywhere. I think something where we'd look at the censorship question, which would be more pertinent, would be something like a WikiLeaks or a Wikipedia or a social network where you have, sort of more pedestrian types of liability arising in very specific cases. So if you're dealing with defamation or libel in the case of a social network, or you're dealing with, politically unpopular speech in the case of something like a WikiLeaks. And then the question would be, let's say you insult the Turkish prime minister. You're some kid in Turkey, and then this message has been encoded onto that blockchain permanently, and you've got someone who's administering that network also in Turkey. The risk is that the Turkish authorities will be able to compel the individual who's managing that network to shut that network down. However, that individual, it's possible that you could spread that out. With Eris, the prototype we made last June, we had two functions. We called them Firestorm and Water Bucket. And Firestorm was something which was held by the administrator of the database, and that was basically, if you broadcast a transaction, the entire structure would shut down and could never be used again. Water Bucket, or the override, as we called it, was something where if you had a sufficient majority of the users of the platform who were active within a limited space of time, if they all agreed in consensus and they pushed a button, all of a sudden the Firestorm override function would be shut down. So you can have that balance between something where the users are in control of the platform and an administrator is in control of the platform, such that to make it censorship resistant, you can do so. But, there will be consequences as to how that network is run and managed as a result of any user governed action, which changes those parameters. With an administrator, it's very straightforward and easy. If you want to just swap someone out, let's say a node is misbehaving and you want to kick them off the chain, that's fine. You just say, right, cool, node, you're gone, and off the node goes. With a user consensus, you then, it's like trying to get a bill through Congress. Well, this node is misbehaving. Well, what about democracy? What about this? What about that? And it takes longer for those decisions to be made. We think that it's important to give people the optionality to explore those sorts of things. There isn't necessarily a perfect one-size-fits-all solution to which consensus parameter works, because it will change on a fact-by-fact basis, chain-by-chain basis. Each user will have a different view of how it's supposed to look.
The exciting idea here, I think, is that it can also evolve over time.
Correct.
Even on a single chain, given the tunable parameters of the chain, which means that you can actually create chains that are responsive to external attacks.
Yep.
Meaning, for example, that if you build an entire worldwide network and then you find out the NSA is recording everything. It's kind of difficult to add encryption or to change the levels of centralization or decentralization of that network ex post facto. But with this, what you're saying is, well, maybe we make the network more centralized when necessary, or perhaps under the consensus of the users, much, much more decentralized if it's being attacked at a central location.
Exactly.
You can make it evolve, which I think would throw a huge barrier up for censorship by creating an environment where the applications dynamically evolve and dynamically respond to the censorship stimulus by becoming more decentralized.
Like Preston said before, we also are interested in building applications that don't only use Thelonious. We would like to be able to support applications that don't use Thelonious at all from our distributed application server. But in the context of this particular conversation, if an application developer is worried about censorship, they can always drop a hash into another bigger blockchain of a particular piece of information. And from the D server, we make it really quite easy to change where you are and where you sync information into any particular blockchain that has a module for the D server. And so that allows you to say, when I look at my application holistically, I need to use this blockchain for these particular things. And I'm going to use this blockchain for these particular things. And I'm going to use a different blockchain for these particular things. And then what I'm going to do is I'm going to harmonize those in a back-end system that for the D server, we use JavaScript. And you can use JavaScript to have basically quite secure oracles that run on users' computers or on servers if you're running D server remotely. And then you can sync information where the application developer thinks that needs to go. And that's what we really want to do. I mean, Thelonious maybe will work for some people, maybe it won't work for some people. It will work for some things, it won't work for other things. And what we really think is most exciting here is being able to use multiple blockchains in a cohesive application, being able to partition which information needs to go into a highly secure Bitcoin style or eventually Ethereum. And we hope Ethereum will be really secure, and because that will be super beneficial to have a smart contract enabled, very secure, very public blockchain that can be used for some things, but you probably wouldn't want to use it for everything because of that security. It's going to be quite expensive to use. And that's what we're super excited about people trying out. ErisIndustries.com is your starting point for everything. ErisIndustries.com. We're also Eris Industries on Freenode. If people have questions, stop by our IRC channel. From ErisIndustries.com, you can find links to all the projects that we're working on.
And we're also Eris Industries on Reddit for those of us who are less technically inclined.
Thanks for listening to episode 179 of Let's Talk Bitcoin. Content for today's episode was provided by Andreas, Casey, Preston, and Adam. Music for today's show is provided by Jared Rubens and The New Time. This episode was edited by Grant Strack and Adam B. Levine. See you next time.